Alright, today's exercise is to be able to classify a quadrilateral when we're given the vertices. So, the idea is this. We have, these are supposed to be the vertices of some quadrilateral. We don't know what it is. It might be a trapezoid or a kite. We don't know. So, here's a random quadrilateral. So let's say this is quadrilateral ABCD. So I'll just put ABCD. And these are the ordered pairs. So obviously the four sides of this quadrilateral are the following. So just fill this in your table. We have AB, BC, CD. Okay, that's these three. And finally AD. Or DA, doesn't matter. Okay, so these are the four sides. In the past, I've given you the lengths and the slopes, and we just had to classify. And that was a good place to start, because I wanted you to focus on what made each shape different. But now you're going to have to go back to finding the lengths and the slopes yourself. But you do know how to do that, so it shouldn't be a problem. So, for example, if I want to find the length of AB, I'm going to use the distance formula. So the length of AB, I'm just going to use the distance formula. So I'm looking at the x values, so I'm seeing 2 minus 1 squared. And then I'm looking at the y values, so that's -1 minus 3 squared. And that should give me length AB. If I put that in the calculator, that turns out to be the square root of 17. So that's the length of AB. And I'm just going to do that 3 times to find, 3 more times to find the other lengths. So here's the setup for length BC, and this turns out to be the square root of 29. These are the calculations for length CD. That turns out to be the square root of 17. Alright, there are the calculations for AD, and that turns out to be square root of 29. Now, remember, the first thing that I have to decide as I'm classifying is this a parallelogram, a trapezoid, or a kite? Based on this information, based on the lengths alone, you should be able to tell me right now whether or not this is a parallelogram, a trapezoid, or a kite. What do you say? Okay, I'm hoping you can see that this is a parallelogram. Now this is not my final answer. I'm just going to write down what we have so far. I know this is a parallelogram because the opposite sides are congruent. Okay, because of the way I wrote these sides in order going around the shape, I know that AB and CD are opposite sides. And I know that BC and AD are opposite sides. And opposite sides are congruent. That will only happen if this is a parallelogram. So I can forget about kite or trapezoid. The reason why I'm not done is I need to know, it's possible that I can be more specific. Maybe this is a rectangle. Look, okay. So I know this thing is not a trapezoid, and I know it's not a kite. It's going to be some kind of parallelogram. Is it possible that this is a rhombus? Alright, is there any way this could be a rhombus? No, there's no way this could be a rhombus either, because a rhombus has 4 congruent sides. And this, the sides are different, so it's not a rhombus. But it could be a rectangle, and I won't know whether or not it's just a parallelogram or whether it's more specifically a rectangle until I get the slopes. So that's why I have to go ahead and do the slopes now. Now, if this is a rectangle, what are we looking for in terms of slopes? Okay, say this is a rectangle. How should these slopes look compared to each other if this does turn out to be a rectangle? Well, remember, the definition of a rectangle is it should have 4 right angles. Right? That means all of these sides should be perpendicular. So for example, if this slope turned out to be 2/3, then what should this slope be of the next consecutive side? This slope should turn out to be -3/2. In other words, if this is a rectangle, consecutive slopes should be opposite sign and reciprocal, meaning upside down compared to each other. So let's find the slope and see if we have opposite sign reciprocals. If so, we'll change this to rectangle. If not, it will just stay with parallelogram. Okay, so the first slope. So let's look at slope AB. Okay, slope AB should be, and remember the slope formula is y2 minus y1 over x2 minus x1. Alright? Now, whether, if you want to do 3 minus -1 or -1 minus 3, it doesn't really matter which one of these you consider to be 0.1 or 0.2, but you just have to do it the same way for the y's and the x's. So for AB, when I do my y minus y, I'm going to go ahead and do 3 minus -1, so that'll be 3 plus 1. And then I'm going to do my x minus x, so 1 minus 2. So that's 4 over -1. So in other words, that is -4. Okay, now I'm going to do slope BC. Okay, so that's going to be 5 minus 3 over 6 minus 1. So that'll be 2 over 5. So I can already tell that this is not a rectangle. So the answer is going to be parallelogram, but let's go ahead and follow through and find the other slopes. Okay, so slope CD. That's going to be 1 minus 5 over 7 minus 6. So that's going to be -4 over 1, which is -4. Good thing, because if this is a parallelogram, the opposite sides should be parallel, same slope. Last one, slope AD. So that should be 1 minus -1, or 1 plus 1, and then 7 minus 2. Alright, so that is going to be 2 over 5, just like we got on the other opposite side, so 2/5. Okay, so this is a parallelogram as we predicted, with opposite sides parallel, but it is not a rectangle, and we know that because these slopes are not the slopes of perpendicular lines. Perpendicular lines have slopes that are opposite sign, which these are, and reciprocal. Like this should have been 1/4 maybe. Okay, so now it's time for the explanation. So we decided it's a parallelogram, so we can just say it is a parallelogram because, and right now just work in the definition. What's the definition of a parallelogram? Opposite sides parallel. So we can just say it's a parallelogram because the opposite sides are parallel. Okay, that's the explanation. But as I mentioned before, if we're going with parallelogram, because there was a possibility that it could have been something more specific. When you're a parallelogram, because a rectangle and a rhombus are special cases, we had to check and see, was it a rectangle, was it a rhombus? Now, it didn't turn out to be either one of those two things, but if we're going to stop at parallelogram and not continue all the way down to square, we need to explain why it's not a rectangle or a rhombus. We don't have to go all the way down to square, because if it's not a rectangle or a rhombus, then there's no way it could be a square. So we have to say why it's not a rectangle, why it's not a rhombus. Now you have a choice. You could write it out in words. You can say it's not a rectangle because the consecutive sides are not perpendicular. And then you'd have to also say it's not a rhombus because all four sides are not congruent. So you could write those two sentences. Or you could take the shortcut of just marking that on the chart. So I know that this is not a rectangle because of, for example, these two slopes are not opposite and reciprocal. So I can just put a circle around this and point to it and say not rectangle. Okay, so either write it out in the sentence, not a rectangle, it's not a rectangle because consecutive sides are not, well, okay, you could say it's not a rectangle because it doesn't have four right angles. But I think this is quicker. And as far as the rhombus, we can just put a circle around these two as an example of two sides that are not congruent. And we can just write over here and say not rhombus. Okay, I think that's the best thing to do. So here's our explanation. Don't forget to indicate how you know that it's not a rectangle and not a rhombus. Okay, so these are the length calculations for quadrilateral ABCD. And I should mark this. Okay, so side AB, BC, CD, and AD. Just make sure you put those in order like that. Okay, AB, BC, CD, and then A to D at the end. Okay, so these lengths turn out to be 5 radical 2, 2 radical 5, 3 radical 2, and 2 radical 5. Okay, from those lengths alone, we can eliminate some things. Okay, from those lengths alone, so looking back at our diagram for a second, is there any way this could be a parallelogram? No, a parallelogram has opposite sides that are congruent. So 5 radical 2 and 3 radical 2. All right, BC and AD are looking good for a parallelogram, but AB and CD not so much. So we know it's not a parallelogram. Okay, since it's not a parallelogram, we can really we can get rid of all of these possibilities. That means it's not a rectangle, a rhombus, or a square. So it's either a trapezoid or a kite. Now, is it possible that it's a trapezoid? Well, sure. A trapezoid can have all different lengths. So to see if it's a trapezoid or not, we'll need the slopes to see if it has one pair of parallel sides. So trapezoid is still a possibility. Is it possible that it's a kite based on this? Okay, could it be a kite? That's the third thing. Now, if you remember that in a kite, consecutive sides of a kite are congruent. So remember, a kite looks like this. Consecutive sides right next to each other should be congruent, and there should be two pairs of those, two pairs of congruent sides. So looking at the lengths that we have so far, do we have two pairs of congruent sides? No. First of all, we only have one pair of congruent sides, and those are not even consecutive. They're opposite sides. They're not even right next to each other. So there's no way this could be a kite. Okay? So if we cross kite off the list, that means this has to be a trapezoid. The only question is it isosceles? And that's what we'll have to figure out. Okay, but we know right now that this is some sort of a trapezoid. Okay, if it turns out that BC and AD are the legs of the trapezoid, then this will be an isosceles trapezoid if these legs are congruent. Okay, and that's looking like a real possibility. But we'll have to see the slopes to be sure. For example, slope AB, which is, of course, when we're doing slope again, we're doing y minus y over x minus x. So that's 5 minus 0 over 0 minus 5. That's 5 over negative 5, which is negative 1. On the other hand, when you do slope BC, you get 2 over 4, which of course reduces down to 1/2. Okay. Now let's do slope CD. We get negative 3 over positive 3, which again is negative 1. And then finally we'll do slope AD, and that gives you 4 over 2, which is 2. Okay, so now it's time to decide if this is just a regular trapezoid, a normal trapezoid, or if this is an isosceles trapezoid. So to understand that, we need to know which of these are the bases of the trapezoid and which are the legs. So if this is a trapezoid, the definition of a trapezoid is it has exactly one pair of parallel sides. And we can see the parallel sides are right here. Okay, see the negative 1 and the negative 1? The same slope means that these lines are parallel. So this AB is parallel to CD. These are the parallel sides of the trapezoid. Okay, that means this is the base, and this is the other base. Okay, that means these other sides must be the legs. So that means that BC must be a leg. And that means AD must be a leg. Alright, the non-parallel sides are the legs. And I'm focusing on the lengths because whether or not these are congruent. That's what determines if this is isosceles. So is this isosceles? Sure, the legs are congruent. 2 radical 5 and 2 radical 5. The legs are congruent. So this is an isosceles trapezoid. Alright, just one thing left to do. Now we have to do the explanation. And since this is an isosceles trapezoid, there's nothing more specific, so we don't have to worry about saying why it's not something else. We just have to say why it is an isosceles trapezoid, which basically is going to involve the definition of trapezoid and isosceles trapezoid. So basically, I'm going to say this. It's an isosceles trapezoid because it has exactly one pair of parallel sides and the legs are congruent. So there you go. Alright, last problem. Okay, so once again we need to calculate all of the lengths and all of the slopes using the distance formula and the slope formula. Okay, if you calculate all the lengths using the distance formula, these are the lengths that you get. Right there, you know, the first thing you're supposed to ask yourself is this a parallelogram, a trapezoid, or a kite? Well, you should be able to determine that in 2 seconds. Looking at these lengths, let's start with parallelogram. Is this a parallelogram? Yes, this is a parallelogram. In a parallelogram, the opposite sides should have the same length. So if we're looking at opposite sides, for example, skip a row, these are opposite sides. Skip a row, these are opposite sides. So opposite sides are congruent. That means this is a parallelogram. Okay, so we know it's a parallelogram, fine. So that means it is definitely not a trapezoid or a kite. So we can forget about that. Alright, so parallelogram check. But there are 4 different versions of a parallelogram. It could be simply a general parallelogram, or it could be more specific, a rectangle or a rhombus. If it turns out to be a rectangle or a rhombus, we have to ask ourselves, is it a square? But for now, let's move down and ask ourselves, is this a rhombus or a rectangle? Let's start with rhombus. What's the definition of a rhombus? 4 congruent sides. Alright, if it's going to be a rhombus, it should have 4 congruent sides. Is this a rhombus? No. 7 radical 2, 3 radical 2. It's definitely not a rhombus. Okay. So we can forget about rhombus. Is it a rectangle? Maybe. It's a parallelogram, so it has these opposite sides that are congruent. But that would be true for a rectangle, but it would be true for any parallelogram. To know if it's a rectangle or not, we're going to need the slopes. For a rectangle has 90-degree angles. So every angle of a rectangle should mean that these consecutive sides are perpendicular. So to see if this is a rectangle, we're going to find the slopes and then see if the slopes are opposite, sine, and reciprocal. If we have opposite sine reciprocals right next to each other all the way down, then this will be a rectangle. If we do not have opposite reciprocals, then it will not be a rectangle. Let's take a look. Okay, so if we calculate all the slopes, Alright, the calculations look like this, and we wind up with 1, -1, 1, and -1. So remember, we already decided that this was a parallelogram. We're just trying to figure out if this is a rectangle. So the question is, when I look at these consecutive slopes, are they opposite sign and reciprocal? Well, okay, clearly they are opposite in sign. Okay, we have positive, negative, positive, negative. But are they reciprocal? Well, remember that 1, if I wanted to look at it as a fraction, would be 1 over 1. So what is the reciprocal of 1 over 1? Yeah, of course, the reciprocal of 1 over 1 is still 1 over 1. So these are, in fact, reciprocals of each other as well. So 1 and -1 are opposite sign, and they are also reciprocal. So that means these are perpendicular. So this is a rectangle. Okay? And it's important that it works for all of them, no matter which two I pick, as long as I pick consecutive ones. Okay? 1 and -1, opposite sign, reciprocal. But what if I pick the next pair? Again, -1 and 1, opposite sign and reciprocal. If I pick the next pair, 1, -1, opposite sign, reciprocal. Even if I pick the first one and the last one, okay, because even though they're on opposite ends, it sort of wraps around. So these two would also be consecutive. Okay, but even these two, 1, -1, opposite sign, reciprocal. So anyway, this is definitely a rectangle. So first we found it was a parallelogram because opposite sides were congruent. Then we determined that it was a rectangle because the consecutive sides were perpendicular, meaning that it had 4 right angles. But now we have to check and see, because some rectangles are also squares. So we need to check and make sure that it's not a square. That's easy enough to do. Look at the lengths again. Is this a square? Obviously not. If this were a square, all of the sides would be the same. So it's not a square, but we have to say or indicate somehow why it's not a square when we do our explanation. So let's go ahead and do the explanation now. We are deciding that this is a rectangle, so we can say it's a rectangle because it has 4 right angles. That's the definition of a rectangle. But we also have to say why it's not a square. So what I would do, sort of as a shortcut, is I would just circle 2 of these lengths. If this were a square, these would be the same. So I can just circle these lengths, draw a little line, and just say not a square. Okay, that's what I would do, and that is sufficient. But if you don't like that, and some students don't, you can just put it into words and make a second sentence and say it's not a square because it does not have 4 congruent sides. Okay, so just remember, anytime there is something more specific than what you're choosing, always keep this chart sort of in the back of your mind. Alright, if you're going to choose parallelogram, you have to say why it's not a rectangle or a rhombus. If you're going to choose rectangle, you have to say why it's not a square. If you choose rhombus, you have to say why it's not a square. If you choose trapezoid, you have to indicate why it's not an isosceles trapezoid. But if you choose square, isosceles trapezoid, or kite, you don't have to say what it's not, because there is nothing more specific. You know, looking at this diagram, you can see there's nothing underneath isosceles trapezoid or kite or square. This is the end of the line. This is as specific as it gets. But if there is something more specific and you're not going there, you have to say why you're not going to the more specific thing. Okay, that's it for the homework. Wait, I forgot to actually write the answer. After all that explanation, we should go ahead and write rectangle right here. Okay, now we're done with the homework.